All right, welcome everyone. Have you ever looked at a huge company and wondered how they decide to make, say, exactly 83,452 of one product and 112,670 of another? It's not just a gut feeling, right? Well, a lot of the time, it's actually some pretty elegant mathematics humming away behind the scenes. So today, we're going to pull back that curtain and see how matrix math becomes this incredibly powerful tool for making smart, optimal, data-driven decisions. This isn't just about solving for X in a textbook. This is about finding a clear, logical path to profit and efficiency in the real world. So, here's our game plan for today. We're going to start with a classic management problem, something you'll definitely face. Then we'll start building our mathematical toolkit, starting with a crucial first step, a sort of diagnostic test called the determinant. After that, we'll uncover the key that actually unlocks the solution. That's the inverse matrix. And then we'll put it all together to solve our business puzzle. And to wrap it all up, we'll go over some common mistakes to look out for, because believe me, getting this right is absolutely crucial.
Okay, let's dive right in. I want you to imagine for a moment that you are the operations manager at a manufacturing plant. Your main goal, your whole job, is to maximize efficiency. What does that mean? It means zero wasted materials, no idle labor hours, and a production plan that is perfectly in sync with all of your constraints. The big question, the one that keeps managers up at night, is how do you actually achieve that perfect balance without just guessing?
This right here is the core of the challenge. It's a resource allocation problem, and you just can't afford to rely on intuition. Think about it. If you overproduce one item, you might completely drain the resources needed for the other. What happens then? You get an incomplete production run, you get unhappy customers waiting for back orders, and you take a serious hit to your bottom line. What we need, what a good manager needs, is a method that gives us a precise, provably optimal answer. So let's get concrete. This table neatly organizes a complex reality into something we can work with. This is the very first step in building our mathematical model. So look on the left. You see the inputs required for each unit. For every single unit of product A that we make, we need 2 hours of labor and 4 kilograms of material. For product B, it's 3 hours of labor and 2 kilos of material. Now look all the way to the right. Those are our constraints, our limits for this production period. We have a total of 480 labor hours available and 560 kilograms of material in the warehouse. Our entire challenge is to find that magic number of A's and B's that will use up these resources perfectly with nothing left over. Now, before we even think about trying to find a solution, we have to pause and ask a more fundamental question. Does a single, unique solution even exist? I mean, in business, wasting time and resources chasing an impossible target is a fireable offense. And that's exactly where this concept of the determinant comes in. I want you to think of it as the system's vital sign. It's the first thing we check. You can think of the determinant as a quick, upfront diagnostic test. It's just a single number, a scalar value, that we're going to calculate using the core numbers from our problem, that 2, 3, 4, and 2 from our resource table. And this one little number is going to tell us, right away, whether our production puzzle has a clear, definitive answer, or if the problem itself is fundamentally flawed, and we shouldn't even bother trying to solve it this way. So, how do we calculate it? Well, the calculation is beautifully simple, but its meaning is profound. Let's look at our numbers. A is 2, B is 3, C is 4, and D is 2. We just follow the formula AD minus BC. So first, we multiply the main diagonal, A times D. That's 2 times 2, which gives us 4. Easy enough. Then we multiply the other diagonal, B times C. That's 3 times 4, which is 12. And for the final step, we just subtract that second product from the first. So 4 minus 12 gives us a determinant of -8. And this slide right here shows why that simple calculation is so incredibly critical. Our result was -8. And since -8 is not 0, we now know for a fact that a unique solution exists. There is one single, perfect production plan out there waiting for us to find it. Now, what if the determinant had been 0? That would have been a huge red flag. It would signal that our two products' resource needs are what we call linearly dependent. Maybe product B just happens to use exactly double the resources of product A. In that case, there's no single best answer, and trying to find one is a waste of time. So our first test gives us the green light. A unique solution exists. That's great news. The next logical question is, how do we actually find it? To do that, we need what I like to call the master key that unlocks the answer. In the world of matrices, this key is called the inverse. This is really the golden rule of matrix algebra. Now think back to regular algebra. If you had an equation like 5x equals 10, how would you solve for x? You'd just divide both sides by 5. Simple. The problem is, with matrices, you can't really divide in the same way. So instead, we do the next best thing. We multiply by the inverse. The inverse matrix, that's the A with the little -1 exponent, is the special matrix that essentially undoes our original matrix A. And when you multiply them together, you get I, the identity matrix, which is basically the matrix version of the number 1. So here's the crucial point. The inverse gives us the power to solve for our unknowns, those production quantities we're after. For a simple 2x2 matrix like the one in our problem, there's a straightforward recipe to find it. You swap the two numbers on the main diagonal, you change the signs of the two numbers on the other diagonal, and then you divide this new matrix by the determinant we already calculated. That whole process gives us the exact tool we need to untangle the system and find our answer. And here is where it all connects back so logically. Remember that last step for finding the inverse? We have to divide by the determinant. Well, what would happen if our determinant was 0? You'd be trying to divide by 0, which, as we all know, is a mathematical impossibility. It breaks everything. And that's precisely why a matrix with a 0 determinant is called a singular matrix. It's this special case where no inverse exists. No inverse means no master key, which means no unique solution. See, it's all beautifully, logically linked together. All right, so we know our determinant is non-zero. That means an inverse exists and a unique solution is out there. We've done our prep work. Now it's time to put all the pieces together, apply this inverse, and solve this puzzle once and for all. Let's turn our data into a decision. This slide lays out our entire algebraic strategy. Let's break it down. A is our resource matrix. That's the 2, 3, 4, 2 we started with. X is a matrix that represents our unknown production quantities, the number of product A and product B we need to find. And B is the matrix of our total available resources, the 480 hours and 560 kilos. So by calculating the inverse of A, our A-1, and multiplying it by B, we can directly solve for X. This gives us a methodical, repeatable process that completely replaces guesswork with mathematical certainty. And here it is. After we perform the matrix multiplication, this is the solution we get, produced exactly 80 units of product A and 120 units of product B. Now let's just do a quick sanity check, which you should always do. For labor, 80 units of A at 2 hours each is 160 hours. 120 units of B at 3 hours each is 360 hours. Add them up, 160 plus 360 is 480 hours. It's a perfect match. Now for materials, 80 of A at 4 kilos each is 320 kilos. 120 of B at 2 kilos each is 240. Add those up, 320 plus 240 is 560 kilos. Perfect again. This is the one and only combination that results in 0 waste. And I really want this point to sink in. This is the most important takeaway from today. We didn't just solve a math problem. We developed a concrete production strategy. We created an actionable plan that a manager can take to the factory floor to maximize efficiency and completely eliminate waste. This is how abstract mathematics provides concrete business intelligence. This is how you justify your decisions to your team, to your boss, and to your stakeholders with hard, undeniable data. Now, understanding the theory is one thing, but applying it flawlessly in practice, under pressure, that's what really matters. It is surprisingly easy to make small, simple errors that can lead to completely wrong conclusions. And in a business context, a wrong conclusion can be incredibly costly. So let's cover the most common pitfalls I see so that you can avoid them. Please pay very close attention here. A simple plus or minus sign error in that 80 minus BC determinant calculation can lead you to believe a solution exists when it doesn't. Trying to find an inverse for a singular matrix is a complete mathematical dead end. And this last one is so important. Remember that with matrices, order matters. A times B is almost never the same as B times A. In a business context, these aren't just academic mistakes that lose you points on an exam. These are potentially million-dollar errors in planning, in forecasting, and in resource allocation. So let's end with this question. We've used this incredibly powerful tool for a simple two-product problem, but where else could we apply it? I want you to start thinking bigger. Imagine optimizing a complex supply chain with dozens of suppliers and distribution centers. Or what about balancing a financial portfolio with hundreds of stocks to meet a very specific risk-return profile? The truth is, any system that involves multiple linear relationships can be modeled and solved using these exact same principles. This is the foundation of quantitative business analysis, and it's a powerful tool that you can now add to your own management toolkit.